The periodic table. You don't have to remember all the numbers, but you do need to know the names of not all of them. There are 92 naturally occurring atoms and 20 or more atoms that we've made in universities by smashing atoms together, and for microseconds the two atoms hold together to make a bigger atom, bigger than we've had before, and then it splits apart. And some other atoms that are naturally occurring only last for microseconds, like francium, the most reactive metal. In group 1, the most reactive metals. And group 1 is over here, in the first column. Lithium at the top. Lithium is used to make the batteries of your mobile phones. Lithium at the top. We use lithium to make the batteries of your mobile phones, whereas lead to make the batteries inside your cars. The cars that use petrol and diesel. Because lithium is very light, and therefore it won't make your phone heavy, and also very reactive, so you get lots of electricity out of it. Very energetic. Whereas lead, less so, heavy, but a lot cheaper. Much more reliable for cars, much less reactive, much less likely to set light. So this is technology working on. There were some Samsung products that unfortunately caught fire because of their lithium in their batteries. But they solved that problem now. Lithium, sodium, potassium. They're 3 grey, very active metals in group 1. They give away 1 electron. That's why they're in group 1. You'll also notice that there's rubidium and cesium and francium down the bottom, but we don't use those in chemistry exams. You don't need to remember those ones because they're rare, they're expensive, they're not very useful. I do like saying about francium, named after France, the most reactive metal, down the bottom of group 1. The closer you are to the bottom of group 1, the more reactive you are as a metal. All of group 1. Now, in American periodic tables, you sometimes have hydrogen put at the top, because hydrogen also gives away 1 electron, like all the group 1s. But hydrogen's a gas, it's not a grey metal. So I prefer hydrogen to be put right floating in the middle on its own, because it kind of is on its own. It's not like anybody else. We at first knew lithium, sodium, potassium. They were a triad. And we knew other sets of 3, other triads. Gold, silver, copper. Things that did reactions similar to one another. Chlorine, bromine, iodine, non-metals. So at first the theory was, it comes in sets of 3s. We don't really know why. There was also this theory that kind of the mass doubles each time, how heavy they were, because all we could do with these elements was find out how reactive they were compared to each other. All the reactive metals, the most reactive are in group 1. Group 2 is the second most reactive. It contains magnesium and calcium. Calcium in bones. Magnesium comes in ribbons that makes wonderful white flames in experiments. They might not be able to do that in your school anymore because it's dangerous. You have to wear goggles and people get hurt because students can often not go by the rules that they're told to keep things safe, and then that spoils it for everybody. All the metals are over this side. All the non-metals over this side. And the metalloids down here, but it wasn't arranged like this to make it easier for you. The pattern just happens when you do the science. There's 2 atoms on the top line called the top period. Periods are things that repeat and repeat and repeat and repeat. Going, noble gas, I'm not reacting. These are the noble gases. Helium, neon, krypton. Noble gases don't react. Argon, 1% of air. Not react to very reactive metal. Not react to very reactive metal. Not react to very reactive metal. Each time it goes across a period, it goes from not react, noble gas, to non-metals, through metalloids, metals, reactive metals, and start again. All they knew 300 years ago was how heavy they were. They could weigh them. Some scientists called this the atomic mass. Sometimes scientists call this atomic weight. Some scientists called it the relative atomic mass. And other scientists said, can we make that shorter by going relative R, atomic A, mass M, RAM? So yes, they knew how heavy it was, called the mass or the weight by different scientists. They're on different periodic tables, sometimes saying all four of those, sometimes just the favourite one of the person who made the periodic table. But my students need to know all four because they come up in exams. They only knew one number for them. 1 for hydrogen floating around, 2 for helium, and so on, going up and up and up. The atomic mass is how many massive things there are in the middle of the atom. Hydrogen has 1. It's called 1 proton. Helium has a mass of 4. 4 helium. Because it's got 2 protons, 2 neutrons. And people didn't know, hold on, why does it go 1, 4? That doesn't make sense. Surely it should go 1, 2. And then many years later they found out it did go 1, 2. If you count just the protons and ignore the neutrons. Hydrogens mostly have 1 proton. No neutrons,